Hey, hey. Good evening and welcome to Mr. Wilson Live. We are just one to go, but we are loving it. I do hope that you are well wherever you are in the Caribbean. You are in tune to Mr. Wilson Live, and my assistant teacher is here with me, and is usually here at the start of the show, sometime in the show, but he is always around to do his little checkup. This evening we wanted to have some things done. I am not on time because I was having some problem. The regular problem I usually have. So it was resolved just now, so I am on. Well, how are we doing? I'm not seeing a lot of persons. I'm not too sure if we did not see the thumbnail for the show today. But we have a show today, and we have another show on Friday. We have another show on Friday. So we want to see what we can get out of the day today. I'm seeing Jennifer here. I'm seeing Cheryl here. And I'm also seeing Barnett. I'm seeing Green. I'm seeing Cheryl. So I'm seeing about 5 persons in the room. And of course, there are those who are in Yonderland. I'm having a little headache. I'm not too sure what's happening. I went to work today, but I'm back with a little headache. So I might sort of change up what I have planned for you today, but you'll definitely get it. We might look at a past paper today, but we're going to be doing something that makes sense today. No need to worry. All right, I'm seeing a lot of persons coming on. Anai, you're just going to be yourself on me today, all right? Cool? All right, great. Nice boy. All right, hi, nice boy. All right, let's let you're a nice boy. All right, great. Wonderful. Yes, wonderful. Yeah. Yeah. Yeah, they know that you're saying grandma now. Yes, you're saying grandma now. Yeah. All right. Thanks, Masher. All right, Jawawan, how you doing? Shaw. Lifestyle. Good evening. And I'm seeing Green. I don't know if I've ever seen Green before. But if I've never seen it before, welcome to the show. Welcome to the show. And I do hope that you will like, share, and of course subscribe so that we can continue to serve you to the best of our ability. We're going to be doing a paper today. I have something lined up. I want to have a discussion around a part of the syllabus that usually we are debating that part of the syllabus. Not so good, sir. You took the vaccine and you've been out of it. Oh, tell us about that experience if you can. Definitely we want to know about that. Guys, if you observe, I did post some video link in the session just before I came on. You can, of course, partake in those. I am sort of waiting on everybody. This is like the community section of the show. So I wait on persons to come on and I listen to what you have to say, questions that we can answer, we answer, and that sort of a thing. But we want to look at a past paper today that is going to run us some long time. I'm going to publish it afterwards, but I'm going to give you an opportunity to answer it for those persons who don't mind answering the questions. We're also going to be looking, I want to also look at a little bit on population growth, and I want to use some statistical terms in today's show. I'm going to ask you to help me with those statistical terms. I am going to be drawing, sorry about moving the computer all up and down. All right, I'm going to be drawing some lines, and I'm going to ask you to just describe what is happening with the curve. Now, please be reminded that on a graph, any line that is on the graph is actually called a curve. However, we can describe these curves and whatever we're testing, usually, whatever happens would inform what happens to the curve. So I'm going to be starting there just with a little practical exercise that we can sort of get up to date with curves and be able to solve them on your exam. So Anna, you're going to go down now, and I'm going to do some drawing. Is that fine? Right, great. So go over there and play with that. All right, nice boy. All right, see you later. Nice boy. Hey, nice boy. Nice boy. All right, great. All right, so I say I'm going to be starting off with some lines, and these lines are really important for you to interpret graphs. In most cases, the bias student, but this is not a life lesson. When we talk about analyzing data and data representation, I don't think that we're doing well, and I want to just start off with that. I'm just going to draw some random lines, and you tell me what these lines mean in the chat. All right, and we're looking at graph, but I'm not going to draw the axis because I'm just teaching the concept. All right, I took my first dose about almost 2 weeks ago. When I took it, I was normal. Until a few days ago, I have been getting a lot of chest pain. Okay, in between feeling like I have a hole in my chest. Interesting. So now you know what you're doing to the show now. You are now forcing me to go back into time. And this time I don't even want to tell you from my lips, so to speak. I want to read, or I am going to ask somebody to read. I shouldn't say it because I don't want to get into trouble. I want persons to tell me what happens when we have a inflammatory response. We're going to look at that. What really happens when we take the vaccine or take a vaccine? What happens to the body? How the body responds to it? Now, I'm asking in particular with the blood vessels. What is going to happen to the blood vessel? What is going to happen to the blood? What is going to happen to the heart? Now, what you are saying is something normal. It's an effect that you should get. Now, as to how long after that happens, I'm not too sure. However, it sounds pretty much like that which I expect to happen, most persons expect to happen. I'm going to ask you to assist us in explaining that, why you'd be getting that, response, having took the vaccine or having taken the vaccine. Why would you have that response? What is happening? We want to know. All right, so anybody can give the suggestion? James, how are you doing? I am getting the feeling that you are a newcomer based on what I'm seeing in the chat. So anybody want to tell me what is happening with her? So this could have been a CXC question. We're looking at the inflammatory response. Tell me what is happening as a result of taking the vaccine. Tell me about the body's response, why Jawawan is feeling the way that she's feeling. All right, anybody who wants to take it up can. That would be nice. We're going to just have a real life conversation. Usually when we do these labs, we're asking the questions, how does this impact life? So now here we have a real case of someone taking the vaccine. And having taken the vaccine, she's communicating some, is it sign or symptoms that she's communicating? Anybody want to tell me there? Anybody want to tell me? You have to respond. And if you don't respond, then I don't know what you're doing or what I should do. Okay, great. It is a symptom because she has to communicate that to us. Now, I don't know how many persons would have, I'm going to show you a book on screen. I am not advertising the book. I've never been paid to advertise anything. All right. So I'm going to show you a book on screen. How many persons would use this textbook for HSP? All right. This is just one of many. If you use this textbook, let me know. And then I'm going to give you some further direction or some further directives. Oh, I was saying that James, welcome to the show. Based on what I've seen there, it is suggesting that you are new. You had the book and you lost it. Okay, great. Welcome to the show. And of course, remember to like, share, and subscribe. We're not going to be here for very long for you guys. I'm going to tap in every now and then, but not to have a class because by Friday, we should finish with the syllabus. I'll be doing like past paper if I pass by, right up to the exam. I'll be doing something. I don't have it. Me, sir. All right, great. So can have it. Now, can if you look at page 312, where you are looking at inflammation, right? What we're looking at is what pretty much happens when a pathogen enters a individual. Now, this is not my work. This is not my work, so let me put that disclaimer out there. So I am reading from the book Human and Social Biology for CSEC Examination by Phil God, and the series editor is Dr. Mike Taylor, and the publisher is, of course, Macmillan Education. So the content that I'm about to share with you, it is not my content, and CSEC Biology TCP does not accept any rights to the content that is now going to be shared. So if there's any royalty, it belongs to the author of this book or his or her management team. All right, great. So I'm looking, it says here inflammation. And the book is saying that the change in a tissue showing its reaction to injury is called an inflammatory response. All right, great. No, not the green one, not the green one. It would have been earlier in the green one. Remember that immunity is in the first part. When you look at circulation for biology, that's where you're going to find immunity. But as it were for HSB, immunity is more in the back of the book. All right, so let me read that again, guys. And remember what we're looking at now. We're looking at the COVID vaccine, and we're looking at Jawawan's response to the vaccine. And we are trying to find out here whether it is norm for her to feel that way, or pretty much if she needs to see the doctor. All right, so I am reading from the book I quoted just now, and I am on page 312, and it is looking at inflammation. That's what I'm reading. So it said the change in a tissue showing its reaction to injury is called the inflammatory response. It continues to say, first, the damaged tissue release a chemical called histamine. This causes the blood capillaries to dilate. When blood capillary dilate, what happens is that they become bigger. So we have heard about the term dilate when we're talking about the blood capillaries. We have heard, when we're talking about the blood vessels, we have heard the term capillaries when we're dilate. Sorry. The word dilate comes up again when we are talking about the eye. So we are saying if something dilates, it becomes larger, and if it constricts, it becomes smaller. Let's continue. The permeability of the capillaries increase to release more white blood cells near the wound. Now listen, the permeability, what it means is that the capillaries become more porous, so the white blood cell will pass through it much easier. Let's continue. Histamine is the reason, careful. Histamine is the reason pimples caused by bites in the skin are red. If you have a cut in your skin, note the redness around the cut. not the redness around the clot, sorry. The extra blood supply in all these cases speeds up the healing of a wound. Now, what I want to point out here, and I'm not wearing my glasses, what I want to point out here is that the histamine that is pretty much produced will definitely cause the blood to move faster. Now, the blood will not move faster unless the heart works harder. So if a heart is working harder as a result of you taking that vaccine and the white blood cell need to get there and try to do some work because you think that the body is pretty much under invasion, then the chest will definitely have this type of a pain. And of course, your body temperature will naturally increase as well. And of course, you might sweat and you might have pimples and all of that. So these things are pretty much normal. Now, with that said, I don't know if it is a good idea if you have underlying condition like a circulatory problem that include like high blood pressure, thrombosis, those type of things. I don't know if it is a good idea to take the vaccine. And I strongly suggest that persons who are going to be taking the vaccine, you make sure that you are in the know so that you don't take that vaccine and then you become a statistic. So try to find out, all right? Great. So symptom, blah, blah, blah. I have green one, or the green one is biology. Thank you, sir. Great. I have the Nelson and Thorne Caribbean study. Okay. I'm scared to take the second dose. All right. So again, there is a graph in your textbook that you are supposed to know, and it will definitely show you what is happening when you take that vaccine. And I'm going to show you from this textbook, if you can screenshot it, if you can see it and you can screenshot it. So there it is. Look at these graphs. When you take that vaccine, this is pretty much what is happening. All right. And like I say, this is not my book. It is from this. This is the book that I'm showing you from. So I am not actually trying to claim rights to the content. It is not my content. All right, so look at those things. It is something to have a discussion about whether or not you should or shouldn't. I don't know. I am not a doctor, and I don't have a whole lot of knowledge around this vaccine thing. And you have to check a doctor or the medical professionals as to how you should treat that. I think it might be normal. Listen. It kind of it's sort of normal to behave that way, but one I think that you'll find happening is that for some persons the body will behave differently. All right, so some persons might have this feeling that she's having, some persons might not have that feeling. But if it persists, I suggest that you see your doctor and let them know what is happening to see if it is doing more than it should do. The immune system needs boosting. All right, Douglas, I am not even sure if what needs to happen. I really don't know. I am not a doctor. All right, so I don't know if Douglas could shed more light on that for us. I really don't know, sir. Put it back up. Uh, okay, great, great. But you could find it online. You know, you could find these graphs online at Google. It says the antibody concentration after 2 injection of a vaccine. So type that in Google. It said the antibody concentration after 2 injection of a vaccine. And then the other graph said antibody concentration after, it said 2 injection of anti-serum. So one is looking at anti-serum and the other one is just looking at vaccine. Both are dealing with, of course, immunity. So these are two graphs that you need to be able to interpret. But if you go to the exam and you don't know them, looking at a graph, you should be able to interpret the graph. All right? I have a book, sir. Great. I was just asking persons to just turn to a page and see if they can analyze the data. To be a doctor for a second to suggest to Jawawan what might be happening. All right, so I did promise you that I'm going to be drawing some lines. And it's not all the time you're going to come here and get this whole lot of notes and teaching. Things will change, all right? So for those persons who are new, just try to learn what I am doing. I'm not really playing around. I am really doing the work. All right, so usually when we get a graph, we're supposed to draw the axis, all right, there. So you're going to have the x at the bottom. You're going to have a Y at the top. All right, great. Usually we put on an arrow at the end, an arrowhead at the end, or we could just draw an arrow beside the line to show the direction that it is increasing with. So you have seen an arrow there, and you have seen an arrow here. All right. So naturally, it tells me, or it suggests that the 0 point here is the point of origin. All right. So that is where both sides will begin. Great. So with that said, I am going to draw a line on the graph, and I want you to interpret. Tell me what this line means, what this curve would mean, having seen it on a graph. Let me see what, use red marker, sir. The lines are pale. I understand the lines are pale, but I don't know if I have all that resource. Just let me check. I had a blue marker here. All right. Sorry about that. Let me see if I can help you with this. All right. So the class taking a little different turn, but don't worry yourself. All is well. All right. So, and sometimes these things is based on some observation that I would have made. And I think that all students probably will be having the same problem. So when I see that, I will sometimes just say, you know what, I want to share this with you, because probably you could just go and read that in the book. All right. So it is something like this, a graph. All right. Great. So I'm going to be drawing a line, or what we refer to as a curve on the graph. What does this line say about what is happening on the graph? So that line, what does it tell you about the activity on the graph? Type it in the chat for me. That's all I'm going to be doing, just showing you some lines and you interpret the line. What's happening with the activity on the graph? If you want me to name the axis, I could give you names for the axis. So I'm going to give you the y-axis as population, and I'm going to give you the x-axis as time. All right. So there we have it. Probably you can say the y-axis is population and the x-axis is time. All right, great. So now I want you to interpret that curve I drew on the graph just now. Tell me what it means. I don't know if I'm logging, but I'm not seeing anything. You're watching Mr. Wilson live. We are streaming from Kingston, Jamaica in the Caribbean. We are like one class away from our final class for the year. We should be completing the syllabus by Friday. The population is constant. All right, so somebody said that I am lost, sir. The population is stable over that time period. All right, Jawawan. What we're saying, yes, guys, you are correct. What we're saying is that inscribing the trend on a graph or looking at the trend, there are some statistical terms that you need to know. Now, when you see this, it says that things are pretty constant. And how do we know that it is constant? This line is showing that it is going up. This line is showing that it is going this way. But if you observe, there's no increase in the population. The population is the same over time. So time is here and the population is the same. So if it's 10% in the population, it remains 10% over time. All right, there's no increase in the population. It is pretty constant as, and I don't do that. All right, so it's pretty constant over time. So that was my line. I'm going to label it A, that there is. I'm going to label that A. Sorry about that. You will have a little about that. Understand. All right, great. So I'm going to label the other line B, but I'm going to just use the graph as efficient as I can. So I'm going to be showing you this now. All right, so you're going to tell me what B means. So you're seeing this on a graph. How would you interpret that? B, what does that mean? So we said that A is constant. What's B? What's B? How would you interpret B? All right, you're going to be a nice boy now, all right? Don't go under there. Don't go there. Go play with that. All right. So we want to know, what's your interpretation of B? What does B mean? When it used to be on a graph, what does it mean? All right, fluctuate. The population is fluctuating. B's population is constantly fluctuating. All right, so they speak to even a constant fluctuation because it's pretty much going right across. I am seeing that, and then you observe there is two words now being used there: fluctuate and constant fluctuation, which means that it's fluctuating within a particular frame. It's not, you're getting some nice craft, trough, and is it trough and what is it called? I don't know. I just lost those words a while ago. I hope they come back to me in a short while. All right. So what we have is that the fluctuation is about a point. All right. So we say that it is really constant fluctuation because you're not seeing anything going up and coming down and this opposite thing. It's pretty much even going across. All right, great. So those persons who are not following, we're looking at some little graph skill and we're trying to interpret some curves, what the curves mean. So I'm going to draw another curve now, and this curve, I will call this curve C. So what is this curve saying? C. Curve C, what is it saying? What is curve C saying? Type it in the chat there for me. Curve C. So we started out with being constant. Then we went to okay. I want everybody to take part now because I want to know what is in your head and how I can correct it. All right, I am seeing fluctuate coming in, so I suggest that when you send in your answer, you say, well, C is that and B is that and what that type of a thing. All right, so we know exactly which question you're answering. All right. Okay, so there is a decline in the population. I hope that persons are seeing that. So if you didn't know, you could just write it down in your book. All right, so we are seeing a constant, and we are seeing then B fluctuation, and then we are seeing C, which is a decline in the population, and then we are going to go the other way now. We are going to go for D. What's D? Look at D. What is D? What does D represent on the graph? It's going down. It is going down, but we have to use those statistical terms. All right? So we have to use a statistical term. D is increasing, that's nice. And we can say decline, yes. All right, increase, so D is increasing, very good. Very good. So those were like the base words for graphs. Increase of population over a short period of time. Great. And population increase. All right, great. So I like what I'm seeing there. I like what I'm seeing there. Now, these are just the base words that we can use with a population. And I'm going to continue on the line with the curves. I'm going to show you some more curves. So we have looked at some. We have looked at fluctuation. We have looked at constant. We have looked at a decline in the population or a decline in the activity of the enzyme or an increase in the act. So we could look at population, we could look at enzyme, we could look at any reaction. And we're looking at an increase in the rate of reaction. But we could even add some, I'm not an English guru, so we could add some more adjectives to these and make things be a little different. So I am going to be now changing the scope of things. I'm folding the paper here. Oh, it won't work. All right, I'll just 7. All right, great. So I'll take that off, and then I'll go with this. And then I'm going to show you a different curve now. All right, great. So now we are looking at this curve. What does this curve shows? What is this curve saying? Oh, the green one is biology, James. It's fine. It's fine. Yeah, I'm not. I wasn't saying that anybody should do anything with the book more than just to read the information that we shared earlier. That's all I wanted. That's why I was asking. I'm not advertising the book or anything. I was just ensuring that it is not said that I'm trying to own the information. All right. All right. So AMOR, it's going to be more than just increase in the population. It's going to be more than just increase. You have to describe that increase. Yes, it's an increase, but describe the increase. Yes, it is an increase, but you have to describe this increase. What type of increase is it? No, not gradual. Not gradual. No, it's more than just increase. It is more than just increase. Because here, it is going to tell us how rapid something is happening. How quickly. All right, is there a cause for concern? So you have to be able to interpret the graph. You can't just say increase. Of course, things increase every day. But we have to use some, it's a steady increase. Yeah, it is a steady increase, but I'm not looking for steady because steady is not so alarming when you look at a graph like this. Can you imagine if they were supposed to increase your workload like this? Look at what we have here. What better word could we use to describe that graph, that curve? All right, so what better word could we use to describe this than an increase or just a steady increase? Yeah, it looks like a steady increase. Pretty much, it is a steady increase. It is a steady increase, but a steady increase could be 1, 2, 3, 4, 5. It could be 10, 20. It could be 100, 1,000. Yeah, so we really want to have something that it connotates a meaning that you have to look, you have to respond to the data, having heard of the data. All right, so we don't really want, we want it to be what it is. All right, true, so rapid increase. All right, drastic. So it is a drastic, but I'm looking for an E word. I'm looking for an E word that speaks to 2, 4, 8, 16, 32, 64. That type of an increase. I'm looking for that E word. Yes, it is rapid, but I'm really looking for that E word, which is sort of a smoother term to use with this thing. I'm looking for that E word. No, not even. I can give you an X. So I gave you 2 letters. I gave you 2 letters, and we're trying to solve for this curve. What is the name of this curve? What name can be given to this curve? So you are describing the data on the graph. What name can we give to that curve? Excessive. All right, I'll give you another letter. There's a P in the word as well. So I gave you two letters. I gave you EX. And then I'm saying also that there's a P in the word that describes this line. It's not excessive. It's, well, I wasn't thinking about explosion. It could be an explosive growth. No, it's not expand. The explosive is really, really close to it. But I'll use explosive to do, I'll draw a graph that is something explosive. Because remember, when something is explosive, it is like bang. All right. So if I were supposed to draw like a J curve, if I were supposed to draw like a J curve, just let me quickly draw this here. I hope I won't. If I were supposed to just, all right, so this would be more like an explosion. So we started off slow and then bam, it just went up. Bam. All right, this is more like an explosion. Bam. All right, so you see this go like right up. All right, so that's not the word that I'm looking for. It's not extension. It's not expand. It's not really exploding. I did show you the J curve is something more, to my knowledge, of a curve being exploded, or something you could say it's an explosive growth, right? Because you just had 20 yesterday and now you have 1,000. That is like bacteria are replicating, right? So no, it's not that. Give me all of those new words to add to my vocabulary. Alicia, I've never seen you before, but welcome to the show. Please be reminded to like, share, and of course, subscribe. I am liking that word. The word is exponential growth. The word is exponential. So it is increasing in doubling. It is doubling in increment as it increases. So if you were supposed to draw a scale here and draw a scale here, what you would find out mean is that here, 1, 1, then would go up 2, 2, and then you see 4, and it would start going up like that. And you realize that it is really increasing exponentially. All right, so that is really a good move. Thank you very much. Who was that again? Alicia, thank you very much. All right, explosive. Remember, we said that explosive is something more like the J curve. I'm loving it. So, which curve didn't I show you? Just tell me in the chat there. Which one? So, we talk about exponential growth. So, I need to show you another curve. You know that we talk about moderate or drastic. This could be something drastic as well, but we use the word moderate. That's another term that we use every now and then. So let me just pull a curve for that one for you. Something a moderate increase, marginal. You know those words? It's not a big thing. Marginal, not a big thing. So you're having something like this. All right. So somewhere along this graph, you'll find marginal. All right. The increase is just a little bit in a bit until you see it start taking off. So up to about this point here, you see just a marginal increase. It's not a big thing, and then it changes over time. All right, sir, can you explain the pie chart? Oh, sure, that's fine. That's fine. All right, great. So marginal, if it's marginal, it's just a little bit. If you don't understand the Jamaican, we accept that we speak Jamaican. All right. One might say English, but I say Jamaican. All right, because we throw with the S, or we throw with the TH and that type of thing. So if you don't understand, just let me know. All right, great. So here we'd have some little marginal growth right here, and then it would have changed over there. So I want to talk about marginal, expensive. I didn't see that. I didn't know. I didn't see that. All right. All right. So thank you, sir. Great. All right, sir. Can you explain the pie chart? Drastic fall in population. Okay, the drastic fall in population would have been drastic. Yes, drastic. A drastic fall in population. I think probably could have been explained two way. It could mean that you are going. The 2016 paper, biology paper, with the enzyme going up to optimum at 40. I'm going to publish it before the night ends. Going up to 40, and then you see just dying off. That's a drastic fall. Or if you can think about a bell curve pretty much gives you a drastic fall. It's not slant. It's like bloom. All right, so that is more like drastic. Everybody would know a bell curve, I hope. All right, so let me draw a bell curve quickly. That is how your exam results usually look. All right, so optimum is in the middle here. All right, so you are seeing optimum in the middle here, the highest point of efficiency, and then we fall off, right? So this is pretty much drastic if you ask me. All right, we could draw a line of best fit if we are doing physics, but that's not what we're doing. All right, so the dotted line, you probably could look at that. All right, great. All right, so somebody asked just now, sir, please, sir, those are new to me, lol. But I'm learning. Thank you. Are you a bio or HSB student? All right, so I tell you that I'll change up a little thing, and sometimes the little things that I change up, if I have a little class and I realize that our students are struggling on a little topic or two, I will just come to the class and I'll check you guys. And what I find is something usually common. All right, so I'm going to leave you with some words this evening as well. I am going to see if I can get some resource and come back. But just let me move on into what we call the pie chart. And Java one is you always tell me must teach a graph. All right, you might catch me this evening. So I am pulling off papers. This was not my lesson for today, but I am going to be doing the pie chart. All right, so the pie chart, it shows the amount out of what we refer to as a whole. All right, so if you want to call the whole 100%, or you want to call the whole 360. But if we are working with a pie chart, the thing about the pie chart, all right, great, that's fine. The thing about the pie chart is that you need a protractor to construct a pie chart, and you're going to need a compass. Now, each part makes up a whole. So we're going to look at, I'm going to give you some data now. I'm giving everybody the data, everybody. So just let me write it in the chat. Well, these make up the whole. So I'm going to type them in the chat. So 25, 40. I hope that when I'm finished, I can calculate these. 60, 100. I'm just going to give you another 10. All right. So here you have a data set. And that data set is supposed to be represented on a pie chart. I don't know what it represents. You can give each of them a name. I don't know what you're representing. But everything on the pie chart would have represented something. Now, in order to calculate and represent this information on a pie chart, you are going to do this. Sir, if I'm doing both HSB and biology, can I just study biology and do both exams? You could, but you wouldn't be properly prepared, because the depth that we go into when we are looking at HSB, as it were, for disease, we don't cover so much the disease in biology. All right, so you are going to be at a disadvantage when it comes to the diseases. You are going to be at a disadvantage when it comes to sewage. You are going to be at a disadvantage when it comes to water, and you're going to be at a disadvantage when it comes to like the future technology for the future LSD 50 and so on. You're going to be at a disadvantage because we don't cover them type of stuff in biology. All right, great. All right, so I'm going to ask the mathematician in the room. Is there a mathematician in the room? Tell us how we represent that data set in a pie chart. I'm sure there are some gurus here, and I don't want to take away the spotlight. All right, so we want to represent that data set in a pie chart. What do we need to do? Anybody want to just put the first one on the screen? What do we do? Very quickly, put on the screen for me. Anybody, whether you are new, whether you are watching from distant land, just put it on the screen. Pie charts are usually on the exam paper representing a balanced diet. Usually when you see pie chart on the paper, it is looking at balanced diet, or you'll see a pie chart for soils. All right, where we're looking at the components of the soil. We could use a pie chart to represent that. You could even use a pie chart to represent component of the blood. Of course, you could do that if you have the figure. All right. Expounding. I don't know that one. So who's doing the maths? Nobody not doing it? All right, great. So let us start by adding up these numbers. Tell me how much, what's the sum of the numbers? 25, 40, 60, 110. How much you got? 235. That's what you got? 235? All right, same food chart. Yeah, balanced diet, that type of thing. Yeah, that food chart. So, all right, so you got 235. All right, so out of the 235, we could put 25 upon 235. I hope that I remember this thing. All right, so who wants to calculate now to tell me what portion of this pie would 25 be? All right, so the sum is 235, and we want to solve for the first thing. For 25, what portion would it take up? You know, I think you would do this in maths or something like that. All right, who wants to solve for the first piece? Go right ahead, solve for me. We are looking at the pie chart, and the pie chart is pretty much a way of representing data or pretty much interpreting the data set from a pie chart. We could do it either way. Now, one other thing about a pie chart is that a pie chart is pretty much a circle, and it is measured 360-degree right around, pretty much like a square. So we want to find out what portion of this 360, is it 360? Yeah, what portion of this 360 would 25 represent? So I want to do that maths. Is there anybody in the room who can do the maths? Anybody in the room can do the maths? I'm waiting. Work it out and tell me what you get. It's 10%. All right. I don't know what it is. I didn't work it out. All right. So what I'm going to ask you to do, just write your formula in the chat for me. Maybe I don't remember. Just write what you did. It doesn't really matter whether it's wrong or right. What is important is that at the end of the evening, we all would have understood or would have done some correction to get it. Sir, I got to go. All right. Never mind. Take care. We'll see you tomorrow or Friday. I'm not too sure when. All right. So what's the calculation here? Show us your calculation. How you got 10%? Okay, so that plus that plus that gave you, I don't understand. So where's the 360 in the calculation? Something is missing there, man. Try again. Barnett, tell me what you did. It's not percentage, you know. It's not percentage. It's in degrees. All right, Barnett, tell me what you did. Okay, great. All right, never mind. Just keep going at it and you'll be fine. Barnett, you are doing 100 as well. We're not working percentage. We're working degrees. So it's 360. Not 100, but 360. It's out of 360. So if once you go to 100 there, you are suggesting to me that you are working out percentage. Watson, so I don't know the pie chart. I don't know the pie chart so hard. No, the pie chart is not hard. When we're finished this evening, you're going to see all you need to do is just to add up and put that over that, and just it's like percentage. All right, so remember that it is out at 360 that we're calculating, out of 360. 360, guys. Just stick around and work it out, everybody. Whether you get it wrong or right, it doesn't really matter. Just post your answer and then we can figure out what is going on. All right, so please don't try to burden yourself about I want to get it right or I don't want to get it wrong. Don't bother go there. All right. All right. So, okay. So it is the given data set divided by the total of the data set multiplied by 360 upon 1. What is your answer? If there's anybody who don't understand, oh, Barnett had percentage. Percentage is with the 100, but if we are doing the pie chart, it's out at 360. All right, so is 38.2 the common thing for 25? We are solving for 25. Take out your calculator, use your computer stuff, do it. It's a practical activity. You never know, you might just work it on the, this is just one part of pie chart, however. So when you're finished, I'll tell you about the other. What's the answer? To 1 decimal point, it is 38.3. All right. All right. So I'm going to write down that. So it's you're saying that 25 equal 38.3 degrees. You write a little circle at the top there, the little degree. All right. That's a superscript. All right. So, oh wow, I don't even know how you got to write that. I don't know if I pronounce your name, Shelly. All right. That 38 degree. All right. Somebody said 38 degree. All right. So it's about 38, 33 degree thereabout. All right. Good. So I take it that the other persons are not understanding what is happening. We're solving for a pie chart. Someone said that they were having some challenges with the pie chart, and we are pretty much trying to do the calculation. Now, in order to do the calculation, we have to do some calculation. So what we do, the given data set, we are going to find the sum of the given data set. Then we have to find the portion of the total that a specified data set represents. So we were given the numbers, and you can write them down. I'm going to help you to solve. We were given a data set 25, 40, 60, 100, and 10. All these are supposed to be represented on the pie chart. Now, we can't just take up these and put them on the pie chart like that. It doesn't work like that. What we'll have to do, we'll have to find the sum of this here, and the sum of these numbers would come up to 235. Then we'll have to solve for each of the data sets. So we are going to put 25 upon 235 multiplied by 360 upon 1. We are going to do the same thing for 40. 40 upon 235 multiplied by 360, because the circle itself measures 360. So we want to fit these into the 360. And we're going to do the same thing for 60. 60 over 235 multiplied by 360 upon 1. And we're going to do the same thing for 100 over 235 multiplied by 360 upon 1. And then we have to do the same thing for 10. 10 upon 235, because 235 is the whole, multiplied by 360 upon 1. Now do all those calculations for me, and when you are finished, add them up and tell me how much, what's the total? Tell me the total. All right, so we are looking at the pie chart. Definitely, I am not a maths teacher. I am doing biology, and this is a part of what we cover on both biology and HSB syllabus. From time to time, we have to interpret graphs. From time to time, the biology students, they will have to represent the information on graphs, something that should have been done when they were doing different labs, probably the implementation, probably ecology, probably genetics. I don't know. Different parts of the syllabus, you could use it to capture different labs. So, sir, me and the maths not friend. No, that's fine. That's why we're not doing any big maths here today. All we are doing today is pie chart. We're not doing any maths. We're just doing the pie chart. All right. So there's no need to worry. All right. So being that you're on the maths, maths is not your friend. I am going to help you. I'm going to go very, very slow with you. I'm going to write it on this paper what you need to do. All right. So first of all, we have 25, 40, 60, 100, and we have 10. All right, great. Now what we have to do, so this is the data set that we have. That's the data set. So we need to find the sum. To find the sum, all we do, we put a plus sign between them and an equal sign at the end. And the equal sign will return us 235. So we know that this figure at the top represents 235. Now the next thing that we're going to do, we want to solve all of these individually. So we are going to solve for 25 first. So I'm going to call 25a. So it's going to be 25 upon 235 multiplied by 360 upon 1. So that is solving for the first part. All right. Then I'm going to solve for 40. I'm going to call 40b. So it's going to be 40 upon 235 multiplied by 360 upon 1. All right. And we are going to make this representation going down. So we continue. We're going to use 60 as c. So it's 60 upon 235 multiplied by 360 upon 1. And then we have d, 100 upon 235 multiplied by 360 upon 1. All right, so there we have it. And then we continue down to 10. And we are going to have 10 upon 235 multiplied by 360 upon 1. And of course, you should have your equal sign. And you would have actually gotten the calculation for all. So that's all that we were saying just now for those persons who think that it is so difficult. It's not difficult at all. All right. So let me just go back to the chat here. So the calculation has been done 358 when added. The decimal points would have definitely made it reach 360. So what you need to do is to get the decimal points in to ensure that you have 360. 2 is too far up. 2 is too far away. All right. Now a plane making that 2-degree turn is definitely going to miss your country depending on how far away it took that turn. All right. So we have to get those decimal points in. It's preferable that you use 2 decimal places. 2 decimal places. So instead of use 38.3, you use the other figure. So 2 decimal places you need to ensure that you get it at 360. Is there anybody who is still in the dark? Is there anybody who is still in the dark? All right, so I'm going to share with you one question before we go. All right, great. So you have to get ready for this question. All right, I do hope that we helped you there. Outside of that, we'll have to use like the protractor to do the measurement, but I don't know that I'll be able to teach you that effectively now. Probably you need to Google it or YouTube it, and I think you'll probably find some maths teacher, some maths program that can pretty show you how that is done. I'm scrolling here on my screen and I'm wishing that you were able to see. But if I do go over, you will not be able to see a lot of things. All right, so I have a question coming up for you. And then I'm going to be out of here. I think we try this paper sometime. All right, so I'm going to be doing question number 6 from the 2016 May-June biology paper with you. I suggest that everybody take part in this question. We're going to do this question, and then at the end of this question, if you have another class or you have to run, you could do so until you see the other thumbnail. All will be covered in time. So I read for question number 6. State 2 causes of anemia and describe 2 signs, symptoms of the disease. So anemia. What are 2 causes of anemia? 2 causes of anemia. You got 361 due to 1 decimal place. All right, you are going to have it, might have it a little off here and there, but it should be 360. All right, so it means that something rounded off too much or too little. All right, so you could have low blood count, and that could cause anemia, and low blood count could be as a result of you would have gotten a cut. It could have mean that there's something wrong with the bone and the bone marrow. It could have meant that you are seeing your period. It could have meant that you are deficient. All right, so you have iron deficiency. So those, of course, could cause you to have anemia. You could have be suffering from sickle cell, and that too could have been evident with anemia. Not enough intake of food containing iron, so that's sums to iron deficiency. Great. So what are some of the symptoms? You could have cancer as well, and that could, of course, cause anemia. What are some of the symptoms / sign of anemia? So you did well with that first question there. That was good. All right, so now we're looking at the other question. What are some of the signs or symptoms of anemia? If you're suffering from anemia, what are some of the signs or symptoms? You might feel fatigue. You will have pale skin. You might feel cold on the hands and feet. Fatigue, you'll definitely have some amount of dizziness. Yeah, true. You might even faint. That's true. All right, great. Well, you guys seems to be ready. Weakness, a lone discoloration. What's that lone discoloration? What does that mean? A lone discoloration. Is that the pale skin? All right. Iron deficiency or sickle cell. 600 plus 1. I'm not too sure where that's, James, I'm not too sure where you're coming from with that. But you probably could watch a replay and see what, oh. Low blood count. Okay. Okay, great. All right, so let us continue with this. I'm not so much a medic person, so the 601 doesn't appeal to me much. So you can explain it for us. We'd be happy to learn. All right, as you explain, just let me just read the other question. Sickle cell anemia is caused by the presence of a recessive allele. Persons who are heterozygous and carry the sickle cell allele are more resistant to a type of severe malaria than persons who are homozygous for the normal hemoglobin allele. State what is meant by each of the following terms. Homozygous. What is meant by homozygous? And then I want you to tell me what's meant by heterozygous. Or lower red blood cell count. All right. What is, yeah, that's true. What is meant by homozygous and what's meant by heterozygous? We're looking at the 2016 May-June question number 6. This paper will come out by tomorrow. It's ready to come out, just to put in video format, and you'll have it. All right. So pale skin, pale in the eyes. Yeah, you'll look pale. Yeah, in the eyes. Great. Yeah. All right. So homozygous mean I don't know constant, so it can be dominant or recessive only. It can be dominant or recessive only. I don't understand. I don't understand. Chan, sorry. Low blood count, sickle cell. All right, so we're looking at heterozygous now. Heterozygous has to do with having both dominant and recessive gene. All right, so we use like allele term. We're looking for the word allele. All right, homozygous, alleles that are the same. So if you are homozygous for the trait, you have alleles that are pretty much the same. And if you are heterozygous for the trait, what does that mean? If you are heterozygous for the trait, so homozygous, the alleles are the same. What does heterozygous mean? So homo, same, heterosexual, what does that mean? All right, so have both recessive and dominant. Yeah, it's something like more, but it's allele. So if you are recessive for the trait, it means that you are going to have different allele. All right, so homozygous, you are having the same allele. However, if you are heterozygous, you are having different allele for the particular trait. One is dominant with recessive allele, and one is that they are both dominant. All right, let us not do one. I am afraid of one. I don't like the students saying one because it suggests that they don't know which one. All right, so when we talk about homozygous, we say that they have similar allele or the same allele. If we're talking about heterozygous, the alleles, they are pretty much different. All right, great. So we're going to go a little deeper into solving this question. And you might want to take out your pens and pencil so that I can tag you along in what I would have done. So with the aid of a genetic diagram, show how a man and a woman who do not have sickle cell anemia can have a child who has the disease. What I think I gave this to you some time ago, but now I'm giving you a detailed solution to this question. How is that possible? How is that possible? A man and a woman, they don't have sickle cell anemia, but here it is, they have a child with sickle cell anemia. How is that ever possible? All right, both would be carrier. So here, yes, not the same. All right, so anybody else with anything different? We have two parents, none have, all right, both of them are heterozygous. All right, so we could say that they are both heterozygous, or we could say that they are both carriers. And what that means if they are heterozygous, it means that they have alleles that are not the same. If we should go a little further with some of the words that have been floating around, some persons express it as being they have a recessive and a dominant allele. All right, persons have been using that recessive dominance thing because both parents are the trait. All right, so both parents have the trait for the particular disease. Yes, and that is why that is possible. Now we are asked to solve. We are asked to show how this is possible. Now, one of the things when we are solving with sickle cell anemia is a recessive trait, and the loci or the location where it is found is pretty much the hemoglobin. So it is pretty much represented on the HB, that's the location, and usually we use NS. N for normal and S for the sickle person. So we'll have two parents with HB, NS, because they are carriers. All right, so we'd start out by saying the first definition that you are going to have, you have to define the allele. So you probably define, let capital N be the normal allele, this person is normal, and let S represent the sickle person, this person has sickle cell. And then you are going to go on down now, and after you would have defined the alleles, the next thing that you want to do is to pretty much tell what the parent phenotype is. So the parent phenotype here is that they are both carrier for the trait. That's a phenotype of a parent. After you would have written the phenotype for the parent, the next thing you are going to write is the genotype for the parents. This is how you solve a genetic question for CXC. The next thing you are going to write is the genotype for the parents. Here, the genotype for the parents would have been HB with superscript NS, because HB is pretty much loci. All right, there it is, HB, and then you have a superscript NS. Now, the HB here is just a hemoglobin. It's found pretty much a hemoglobin, or the position where it is found. That's what the HB stands for. All right, so some persons might solve it without the HB, but if you see the HB, don't become confused. Don't become confused. So having written HBNSNS, we know that that is the genotype for the parents. After you would have written the genotype for the parents, now you need to write the gametes. After the genotype for the parents, what comes next is the gamete. The gamete is just simply to pull the alleles apart. So we are now just going to write N by itself, S by itself, N by itself, S by itself again. And this would have been the gamete. All right, so N by itself, S by itself. All right, great. So I'm going to pause and I'm going to do that again for you so that you have an appreciation as to how to solve a genetic question in the exam, providing that you know all the rules for your genetic questions. First, you are going to define your alleles. Having defined the alleles, the other thing you're going to do, you are going to write the phenotype for the parents. Here, the phenotype is that they are both carriers. After you have written the phenotype, the other thing that you're going to write, you are going to write the genotype for the parents. Here, we write the location and the allele. So we have HB, and we have superscript NS, N for normal, S for sickle, and we know that this is pretty much a heterozygous parent, so you observe that it's not 2S, instead it's an N and an S. All right, this is just a convention behind sickle cell anemia. It's not like this for all the others. All right, but once you get used to that HB is at the bottom there, just let it stay and don't confuse yourself with it. Now we're at the point of gamete, which comes after the genotype for the parents. Then we are going to have segregation. This is a question that I've been getting on the persons who have been sending me questions on YouTube. How do I know when to do the genetic diagram versus when to do the genetic cross? All right, the genetic diagram, that cross thing, versus when to use Punnett square. And I am saying to you, unless it is stipulated that you should, for me, I am always going to use the Punnett square, because as you go deeper into biology, where you are looking like at dihybrid cross and trihybrid cross, those cross lines can't help you. It is the Punnett square that you have to do, because you have 64 things represented in a grid. You can imagine if you were supposed to draw that amount of line, you'd have to select somewhere in your classroom and use one side of the wall, or somewhere in your house and use one side of the wall. All right, so what you're supposed to do here now is you are going to represent this information in your Punnett square. Punnett square will do the segregation pretty much as if you were drawing those line. And I put Punnett square is just a rectangle with two lines going horizontal, two lines going vertical, and you would have something looking like this to solve the question. So you'd end up with a grid looking like this to solve the question. Now, wherever they meet, you write the two letters there. So this is a N and this is a N, you write both N's here. This is a N and this is a S, so you write NS here, and that sort of a thing. I'm seeing where somebody is saying that weakness, so I'm assuming that's your weakness. White hand middle, I don't understand. That cross thing confused me. What time will the class over? We are out as soon as we are finished this question. But before you go, the persons who are having problem with genetics, I'm going to give you my genetics playlist so that you can go and watch that. So we are going to be out here in a few. Just let me finish this question. So when you do that cross, what you would have gotten you'd have realized that 50% of the offspring are going to be carriers for the disease. 25% is, of course, going to be sickle. And of course, another 25% will be normal. But this is the last question, and this is where the problem comes in, where the biggest part of your knowledge is called upon. It says that we're supposed to explain why the sickle cell allele is more common in the population in countries where the severe form of malaria is present. So let me read that again. Explain why sickle cell allele is more common in population in countries where the severe form of malaria is present. Now, how do we answer this question? I think this is really the tough question on the paper there. Everything there was a little nice. This is really a textbook answer because I'm sure that it is in your textbook. And by now, you could add an immunity playlist as well. We have an immunity video that I just loaded. I did immunity recently. Before you go, what I will do, ask for the playlist and I'll find them and I'll send them. I'll post them here. Now, this particular question is really interesting. And I'm going to say this to you before you forget. Sickle cell anemia, if you're a carrier for the trait, you tend to be resistant to malaria. If you're a carrier for the trait, you are resistant to malaria. If you are normal, you are not resistant. And if you have sickle cell, you are not resistant. Now, if you observe in the cross we did just now with two carriers, every time two carriers come together, the possibility for somebody to persist with the disease is 50%. The possibility for a normal person to come from that thing is 25%. So what you're going to find happening is that the malaria will persist among the persons who are carrier because the chances of a person being born as a carrier is 50% to a 25% being normal. So what is going to happen normally is that if the 25% are born with malaria, then if the 25% are born with sickle cell, then naturally malaria is going to kill them back then. Now, if the 25% is born normal, malaria is going to kill them as well. All right. However, if the 50% were supposed to be born as carriers, they are going to live and continue to carry this trait for sickle cell. So persons who have the trait for sickle cell, they are not affected by malaria. However, if you have sickle cell, then malaria will definitely wipe you out. Let me see what's happening here. All right, so that takes us to the last question. Now I'm just going to be putting up the videos for those persons who can't find them. I'll put them here. Whitening of a nail. Okay, great. I think that, yeah, now I understand what's happening there. All right, that's for sign symptom of anemia. That one look easier than that you show me, sir. All right, the thing about it is that when it comes to any of these genetic diagrams, I don't think that any of them is really difficult. I think the pedigree chart might be a little more different, a little more difficult, but if you do what you're supposed to do, you should be fine. So sickle cell anemia is much different from sickle cell. So sickle cell anemia is as a result of your cells being sickle. So there are two different things. Sickle cells speak about the cells being sickle. All right. Sickle cell anemia speaks about that low blood count. All right. So it's an anemia that is caused by sickle cell that we call sickle cell anemia. However, sickle cell does speak to you having cells that are deformed, arc-shaped, that type of a thing. So they are really two different things. I like that. I am going to do something like that. All right. Sickle cell. So you want something sickle cell versus sickle cell anemia. All right, great. So now what I'm going to do, I'm going to post those genetics videos for you. For those persons who have interest in knowing how to answer the genetic question, these are comprehensive work that we would have done on genetics. So we are going to be posting it there. I'll try to find you a playlist, and you can just click subscribe and like the videos. Once you like the videos, they'll go to your playlist, and you don't have to go around and wondering where I can find this video or where I can find that video. No, you won't have to do that. Once you like the video, it will become a part of your videos. All right, so just give me a minute. This evening the class took a turn that was a little different than I had planned, but it doesn't mean that you are not going to be completing the syllabus, and it doesn't mean that you are not going to be completing the syllabus in the time frame that is expected for you to. So no need to worry. Just let me fetch you this. So we have 12 videos here for genetics. We might have more. I'm just opening the videos to make sure that all the genetic video are in this playlist. Or you can go to my channel by just clicking at that on that blue icon that says CSET Biology TCP, and that will take you to the back end of the channel where you will find a whole host of stuff on genetics. All right, so great. So I have a copy of it now. So I'm just going to go on play all. All right,
did you know that you are over 200% more likely to be stolen from online? That's why you need Avast. Avast is the free antivirus software that keeps you.
All right, so here you go. Other persons, both the cross lines as you call it, they are worked out in these videos, and the Punnett square.
Hello, I am Mr. Wilson from CSET Biology, the cover page. If you will be doing a biology or human and social biology exam and genetics.
So there you go, you can click on that and you will find information on that. Somebody had asked for something else that we did this week. Let me see what that was. I'll just send you that video as well. All right, so somebody asked for something on immunity. So I'm going to send you the immunity video. And then there's nothing in your textbook on plasma and serum, but the syllabus is asking you to cover plasma and serum. So again, I'm going to be sending you a video on plasma and serum so that when you go to the exam, you can't say it was not done. So just give me a sec, and you're going to get the video on immunity with all the immunity well explained. If they are not, I hope that this is the right thing. All right, so there I would have sent you something on immunity, the video that I did on immunity, and it looks at all the types of immunity, differentiating the types of immunity. All right, you'd have to probably catch one of my live to see other things on immunity. One other thing I need to give you, one other video, the serum, it is there already, but you could just pop these videos. Once you like them, they'll go in your playlist. And having gone in your playlist, then you don't need to worry about how you'll find them again. All right. So remember, we have almost 300 videos on the channel. So it's not going to be so easy for you to say that you can't find a video that suits your need. All right. If it's biology or HSB, we have almost 300 videos there, and we continue to put videos there every day. Past paper, there are several past papers there, both biology, HSB, both paper 1 and paper 2. So you can pretty much enjoy those. Please make sure you make use of all the resources that are available. That is the serum thing I just sent you. Different alleles. When is the next class? Okay, my next class is on Friday. It's between now and Friday. I want to say that, but I am almost certain that our last class is going to be on Friday, because we're expecting that we should complete the syllabus on Friday. And thereafter, if you see me, I am doing past papers, or you can look out for our short series. We have been looking at some of the things that students have been struggling with. Like when somebody asks, what's the difference between sickle cell and sickle cell anemia? Now we give you a 2 minutes video on that so that you are well prepared for the exam. So we have been looking at those short videos. We are working on a couple of them. A lot of them we're working on at the same time. That's like me. So those are coming out. But guess what? You have to subscribe and click the notification bell in order to see. Now, if you are not a subscriber of the channel, some of these videos you will not be able to see them. Some of the videos on the channel, you cannot see them unless you're a subscriber. So if you are one of those persons who just pass by some channels, you can't see all videos unless you become subscriber. You have to be a part of the family in order to make use of all the resources that are available. Okay, thank you, sir. If you have any other free time, I think we'll really like to do a live paper. Who is we? So we can ask questions during the live and things. All right, great. I'm not too sure who is we, but when it comes to the past paper, usually we send out the past papers, and if you have anything to ask, you can pretty much just send it in the comment section. And for those persons who are avid fans of my channel, they know that within a day or two, I would respond to them on whatever the concerns are. Right? So yes, we do that. The challenge with having a live where I can share my screen is that my computer is not as fast as everybody else's computer. So I pretty much have to work with the limitation. I can't even use my computer to upload a video. I use another computer to do that. So I have that limitation, and we try to make best what we have to ensure that we continue to reach these students. And we've been doing that for from September. From the 12th of September, we've been doing that. And I think that most persons are sort of loving what we do. All right, so sorry for if we can't do that, but we are going to be putting our paper. So the 2016 bio paper comes up next. We are going to be voicing that sometime today, providing that we have, he said between now and Friday. Yes, so between now and Friday mean between now and Friday. All right, usually Friday is our last show, but the show that I was supposed to have this evening, which is of course sewage and population, we did not touch that this evening. All right, for a number of reasons. But we're going to be having all the shows by Friday. No need to worry. All right, so that is why I said between now and Friday. If time allows and I can do it tomorrow, I will. Well, I don't think we're going to be on Friday. Friday is going to be it for the show. All right, outside that, it's going to be past paper. Any other question or concern? You are watching Mr. Wilson live from CSET Biology TCP. If you are in grade 10 and you really don't want to fail the exams next year, or to be in a quandary as to where you are going to go and what you are going to do, we have a paid channel or a paid website. It is called TCP Academy, TCP Academy, or you can sign up by saying tcp-academy.teachable.com. Over there, you'll find pretty much everything that you need to know for biology and HSB. We're still working on the site. By next week, Friday, all the prices will be available and the payment method. Sir, what about 2018-2019 May, June paper? We have so many papers on the channel. I don't even know what date we have on the channel or what year we have on the channel. But if you are not seeing it, just send us an email or send us something, and we're going to be looking at that. And that is one of the reasons that we are cutting off the show come Friday, that we can do more past papers to meet your need. All right. Somebody asked me about 2018, and I don't know what's burning about that, but somebody asked about 2019 too. So I'm sure that we have a 29. Let me tell you what I have to come out shortly. So we have the 2016 coming out. I'm looking at the lineup. I have a lineup on my screen. So here, just give me a second. We have the Human and Social Biology, 22nd of May, 2019, that is being worked on. We have the Human and Social Biology, 16th of January 2019. So you are going to be getting those two paper two. They are going to be coming after the 2016. We have biology. We have biology May, June 2015. That will come. They'll come in that order. And we have biology January 2016. All those will be coming out in that order. So yes, I know you didn't hear 2018, but that's a lineup that we had, and that lineup is based on requests that we have gotten. We have put these together to send them out. So 2018, we'll add it to the back as soon as these are over. We're trying our best to send out these short videos, but remember that you have a role to play, my viewers, my family members. If you don't watch these videos as they pop on your screen, the algorithm will not send the video. So if the algorithm is not sending the video for other persons to watch it, then we are not going to keep putting on videos on YouTube, because if we do, they are going to become dead videos. So you know what are dead videos? They are going to be there and they have 50 views and never move from 50, right? So you have to help the algorithm to understand that, listen to me, these are good videos. If you consider them to be good videos, let's watch them, and you watch them and give them some love. And having given them some love and watch them to the end, then YouTube will promote my videos. More persons will watch them, and more person watching the video mean that you will be getting more video in return. So you can't just ask for the video and not watch them, or you're waiting on 2 days before the exam. If you're waiting on 2 days before the exam, then you might just have 2 papers to watch. But if you are watching the exams and we're seeing that meter on our screen moving and the papers are being taken, then definitely we are going to be doing more. If you observe, we are putting out way more HSP paper because there's way more HSP consumer, right? So you determine what we do. If you don't play your part by watching the video, if you don't play your part by sharing the video, if you don't play your part by liking the video, if you don't play your part by bombing up the screen with subscribe and all of that, you understand that it's sort of counterproductive for me to do that. Remember that I work outside of this thing. It's sort of volunteer, but you have to play your little role to make the thing grow. So please be reminded to like, share, subscribe, watch the video to the end. When you get to the end of the video, you are going to see some suggested video. Click on one and watch it again. Or go up to the top section there, see a little round button, white with an inverted exclamation. It gives you suggested video you can check. Or click on that blue icon down there that says CSEC Biology TCP. Go to the back end of the channel. If you go to Mr. Wilson Live, they are in volume, from volume 1 to volume 77 or something like that. And each volume would cover a topic or something like that. Just look for a volume that suits your need. Or you could look for our playlist. You could look for our video playlist, or just look for random videos. Like for circulation, I think we have a video for everything in circulation except blood vessels. We don't have anything for blood vessels, and that is being worked on. But other than that, we cover the entire thing for circulation, everything. If it's not covered as a video, it is covered on a live. So no one can say that I can't find anything, I can't find any content. There's no explanation, because we would have done most of that or done it all. All right. Do we have any other questions or concerns? So remember, if you are in grade 10, I know that everybody is going to pass. I'm asking persons who are in grade 10, persons who are doing the exam for the first time, and you need extra help, you can sign up to our channel over there. And of course, you'll get some of this love, more of this love that you like, content that you like, animation that you like, videos that you like, labs that you like. We do just about everything for you. The entire graph gamut will be there. How to do graph, how to interpret graphs, all that will be there. The maths, everything behind it will be there. So if you are interested, please be reminded to just up on over, send us an email so that we can send you something as to what you need to do, what's the cost, where are we with pricing, find out what is it that you want, which of our product you really want, and from there we could put something together for you. So I'm going to give you the email address now for the channel, and from here you could of course share. And it is cheap. It is relatively cheap, really cheaper than going to school. So for those persons who have differed on the exam and you can't find a school to go, this might be the cheapest way because you don't have to leave home. All you have to do is to log on. All you have to do is to log on, and once you log on, you would have gotten, you would have the thing there for yourself for however many times you want to visit. I know that when you go to your various classes, you can't replay, but when you come to these online classes, you can replay however many times you want to. All right, you can't. When you go to class, you probably say to the teacher, "Did you said that yesterday?" And the teacher said, "No, I said this." Now, what we have here, you can replay however many times you wish, and of course, you have it at your disposal. So I'm going to give you the email address, and then we are going to say good evening. And till then, my system is going a little slow, but I'm going to give you the email address. Yeah. Coming? All right, just give me one second. It's very slow. Oh, well, it says wait. All right, so the email address is pretty much on the back end of our channel. You can just go to the back end and click on About. And having clicked on About, it will take you right into, go to the bottom of the page there. And when you go down to the bottom of the page, you will see email address. Just click on that thing that says email address, and email address will pop up right in front of you. So it says view email address. So all you need to do is to click on it. And having clicked on it, you will come up with extreme solution at gmail.com. All right, so I'll give you the email address before you leave. You can share it with however many persons you wish, and that is how you can reach me. Persons who want to reach me by email, I have questions that you don't want to ask me here. Normally, they ask me the questions there. All right, so thank you very much for stopping by. Please be reminded to like, share, and of course, subscribe. That is how we grow when you play your part. And like the videos, if you have some concern, like somebody would say to me, "Hey, sir, the video on reduce, the audio is too loud." I understand that and I appreciate that. We are going to pull that video and we're going to send another video out that is a little more customer friendly. So we appreciate these feedbacks, all right? So take care until we next meet. The next meeting, you'll see a thumbnail coming out, but you need to subscribe and click the notification bell and select all in order that you'll be notified every time and have full access to all our content. Good evening and take care. Love all my family over there in St. Vincent.